Okay, so we have the negation of a quantified statement, okay, negation of the universal, and the negation of the existential. And again, if X is the set of all birds and f of X is X can fly, then not all X, f of X is equivalent to not all birds can fly. This is logically equivalent to the statement, there exists a bird that cannot fly, or there exists not f of X. Okay, thus, okay, not all X P of X, not for all X P of X, is logically equivalent to there exists X for which P of X is not true. Okay. If X is the set of all students in class and A of X is X is absent today. Okay. Okay. Is equivalent, or well, I'll just say, or can be expressed as there doesn't exist okay. X is set of all students in class. Oh, you know, I skipped a line, I'm sorry. Then, we should say then, not a X, A of X, can be written as it is not true that it is not true that a student is absent today. How would you rewrite that in English? That seems kind of wonky, right? We wouldn't really say it is not true that a student is absent today. How would we phrase that?
The student was not absent today.
No. Did you say no student? Is that what you said? It was hard to hear you a little bit. Yeah, Alex.
Yeah.
There are no students absent today. Okay, or no one is absent today, right? Like you would tell the teacher, right? No one's absent today. right? You're taking roll, right, for the teacher, and you would say, okay, everybody's here. Okay. Okay. You would say, okay, no one is absent, right? Or everyone's here. Okay. So we wouldn't really say it's not true that a student is absent today, but we would just say, hey, no one is absent today. Right? Okay. Or you'd say all students are here. Right? Let's see what this is logically equivalent to. Okay. So this is logically equivalent to, so I'm going to move this over. I can continue on the same line. It is not true that a student is absent today. We would really kind of put it as like no one is absent today. And which is logically equivalent to the statement okay, all students in the class are not absent today. Right? So using a universal quantifier, how would I write this statement in logical notation? Look the last sentence, how would I write that in logical notation? All students in the class are not absent. All students in the class are not absent. So wouldn't that just be for all x? And then what was a of x? A of x was absent, right? So how would we say not absent?
Not a of x inside that parentheses.
Yeah, negation of a of x, exactly. So the negation of a of x. Okay, inside the parentheses. Okay, and so what this tells me is that since these are logically equivalent statements, we can say that thus, okay, the negation of one student is absent is the same as for all are not absent. Okay, or if I wanted to generalize this, I could use P of x. Okay, not any is the same as all not. Not any is the same as all are not. Okay, these two statements, okay, make up De Morgan's laws for quantified statements. Okay, so De Morgan's law okay, say that if I have a not all, okay, that's logically equivalent to one not. And not any, or not one, okay, is logically equivalent to all not. Okay, so not all is equivalent to 1 not, and not 1 is equivalent to all not. Right? Example 1. Simplify. Okay, not any or not 1 of x of p of x goes to q of it, or goes to not q of x. Okay, so we're saying that p of x goes to not q of x, the opposite of q of x. Okay. We got some nots there. Okay. So we want to simplify this. Well, how are we going to simplify this? Well, I've got not any of x. Well, p of p goes to not q of x. Okay, I'd like to change this so that the not is inside. That means that this is going to be for all x not p of not q of x. And how did I get that? I got that from De Morgan's law of quantified statements. Okay, De Morgan's law of quantified statements. This one is just my initial statement. My initial quantified statement. Okay, now I'm going to change this, okay, to a conditional, okay, change from the conditional to just a logic statement. Okay, so we have a property that says if we go P to Q, then that's P and, or sorry, that's
Not
P
P
goes
or
to Q,
not Q.
and not P or Q. Yeah, not P or Q. Oh yeah, this is a P of X. Thank you. Okay, so this is logically equivalent to not P or Q. Not P or Q. Okay, so that's what that guy is. That's my condition, that's my conditional statement, right? That's my conditional identity. Okay. So let's look at this one and apply the same rule. Well, P does not stay P. It goes to not P, but not Q stays not Q. So this is for all x, I've got the negation of not P of x implies not Q of x. Nope, not implies, I'm sorry. Or not Q of x. Okay, and that's my conditional identity. Okay, good. Okay, now I want to bring this negation inside, which is just my regular De Morgan's law. So not of P or Q is the same as not P and not Q. I've got to change that or to an and. So this is for all x, not P of x, or not Q of x. Sorry, and I should have said and. We're changing the or to an and. Okay. So I just bring that inside. Okay. And so this is De Morgan's law. The regular De Morgan's law. Okay. Okay, and now we want to get rid of these negations. So this is for all x, P of x and Q of x. Okay, for all x, P of x and Q of x are the same, what would it be? They would both be true statements, right? They're all true statements, regardless of the x value. Okay.
Tautology?
Say what again?
It's a tautology if that's all true.
Yes, exactly. It's a tautology, exactly. It's always true. Okay. So and how did we get there? We got that by a double negation. Huh. Okay, let's try example 2 here. Okay, simplify. Okay, not all x, P of x, okay, and not Q of x. Okay. So here we're just given a logical statement. Okay, it's not a conditional statement. There's no arrow. Makes it a little easier. Okay. So what do you think we're going to do? Somebody help me out here. Okay. P of x and not Q of x. So this is my initial statement. Okay, so what can I do? The negation is on the outside of the whole thing. So what would be my first step?
De Morgan's.
Say that again, Eric?
The De Morgan's law for quantified statements.
Yeah, for quantified statements, right? De Morgan's law. Okay, so what would that look like?
It would be there exists x and then not, and then everything else.
Okay, so thank you. That is De Morgan's law. For quantified statements. Okay, now what do we want to do? Someone different.
Another De Morgan's law.
Yes, we want to do another De Morgan's law. Just the regular De Morgan's. Okay, Captain De Morgan. So let's do another De Morgan's law. So help me out with that, Bob.
So it would be not P of x. Yes. There exists an x, not P of x, or not Q of x.
Thank you so much. Perfect. Okay, now what can I do? Somebody different. Yeah, Alex, your microphone is really hard to hear. Just FYI. I think you said double negation, but I'm not,
I think I heard double negation.
yeah, that's what I think I heard, yeah. It's really cutting in and out. Is anybody else having that problem? Hearing his microphone? Or is it just me?
Yes.
Yes,
Yes.
yes, okay, lots of feedback, okay, good, thank you. Okay. So, yeah, double negation. Okay, or Q of X. Boom. So, forgot to box my answer. But this is a double negation. Correct?